This is the word problem. Okay. Example 10. Students participating in a psychological experiment attended several lectures on a subject. At the end of the last lecture and every month for the next year, students were tested to see how much of the material they remembered. The average scores for the group were given by the human memory model, which is this equation right here. That is T plus 1. That's 6 times ln. Look in the book if you need more clarification, right? Because I may just copied it out of the book. What does this statement here mean? That is the domain, right? They're telling us they only did it for 12 months, so we can't plug in numbers beyond 12 months, right? And less than 12 months wouldn't make any sense, right? Because time started at t equals 0. Okay, now on this problem, when it says find the original score, that, remember in the exponential, they would say find the initial value. It's the same kind of thing. Original means t equals 0. The for time marches forward. Okay, well, how would you find that? Put in the 0 right there. So here's what we get. F of 0 equals 75 minus 6 times ln of 0 plus 1, which is 1. But by the properties, what is ln of 1? 0. Right? So this is equal to 75. So the 75 represents the initial. 6 times 0 is 0. Right? This is 0. ln of 1 is 0. Forgot it. R there. Okay, now let's see what happens. They say find the score after 2 months. How would we do that? Plug in the 2 for t, right? So f of 2 equals 75 minus 6 times ln of 2 plus 1, which the book has already done for us, and that is 68.4. And then the last one, how do you find the score after 6 months? Okay. F of 6 equals 75 minus 6 times ln of 6 plus 1. Which is 63.3. So by using the ln function, right, we understand that at the beginning of the time, you had a value, 75, and that as time goes on, you are forgetting things, right? You're losing some capability. You're remembering less things. The value's going down, but it's not going down linearly, right? It's not like you lose the same thing every month. Using a logarithm in this allows us to have like the change not being constant, right? It's different every little bit. So that's why the logarithm maybe is useful in this kind of a model, because it helps us to describe something which is not just, okay, it's a straight line, you fall off to 0 at some point. I mean, do you think it'd ever go to 0? I mean, you think you'll always remember something, right? So you probably have some score.